Good afternoon, everyone. Let us start. Remember, we have been learning Chapter 8, Composition and the Structure of Ionosphere. Yesterday, we learned about composition of Ionosphere, and today we shall discuss about structures of the Ionosphere. Now, I will present my screen. Structure of the Ionosphere. That means layers, different layers of the Ionosphere. Now let us read. The Ionosphere consists of different layers with varying density and temperature. And density is the highest near the surface of the earth and decreases with increasing altitude. Okay, so near the surface of the earth, density of the air is the highest and it decreases with increasing height. And accordingly, the column of Ionosphere is divided into 5 different layers depending upon the temperature condition. Okay, depending upon the differences in the temperature condition, we have 5 layers of Ionosphere. They are troposphere, stratosphere, Mesosphere, thermosphere, and Exosphere. Now let us read the different layers. The lowermost layer is here. Troposphere is the lowermost layer of the Ionosphere, as you are seeing in this diagram. Okay, troposphere is the lowermost layer of the Ionosphere, and its average height is 13 km. Near the average height is 13 km and extends roughly to height of 8 km near the poles and about 18 km at the equator. Okay, see, we have also this diagram, one more diagram here showing the structure of the Ionosphere. Okay, see, so this is the lowest layer of the Ionosphere, known as troposphere, and as mentioned in the book. Okay, see, let us say this is the Earth. Okay, and here this troposphere is thin at the poles and it is thick, okay, thicker at the equator, just as mentioned here. Average height is 13 km and extends roughly to a height of 8 km near the poles and about 18 km at the equator. Okay, see here, this is the equator, and here at the equator the thickness of the troposphere is that 18 km. Okay, here at the equator it is 18 km, and here at the poles, here, okay, here and here at the poles it is 8 kilometers. Okay, as mentioned in the book, it is 8 kilometers at the this polar region. Just this 8 kilometer in the polar region. Then means troposphere is thicker at the equator than the polar regions. is mentioned here. The thickness of the troposphere is the greatest at the equator because heat is transported to great height by strong convectional currents. Why the thickness of the troposphere is greatest at the equator? Because heat is transported, okay, to great height because of the strong these convectional currents. Convection current, do you remember? Okay, see, when the surface of the earth is heated, okay, because of the sunlight, then here the heated air will rise upwards, and because of this rising of the hot air along the equator, okay, the thickness is the greatest. That is the point mentioned there, okay. And this layer troposphere contains dust particles and water vapor, okay. Most of the dust particles and water vapor are present in this layer. Maximum concentration is found in this layer. All changes in the climate and weather take place in this layer. Cloud formation, fog formation, then rainfall, snowfall, okay, wind, everything. Almost all the weather phenomena are occurred in this layer, that is the troposphere. And one more feature you have to know is that the temperature in this layer decreases at the rate of 1 degree Celsius for every 165 meters of height. Okay, so this is what we call normal lapse rate. You also may be seeing here in this diagram also, and here. Okay, so here if you see this diagram here at the surface, okay, let us suppose temperature at the surface is 20 degrees Celsius, and as we move upwards, then temperature decreases. Okay, see here, from 20 to then here 10, then 0, then minus 10, minus 20, and when it reaches at height of 10 kilometers, then temperature is about minus, okay, temperature is about minus 50. So in this way, in the troposphere, temperature decreases with increasing height at the rate of 1 degree Celsius, okay, for every 165 meter, okay, for every 1 degree, okay, Celsius, for every 165 meter, temperature will be decreased by 1 degree Celsius. And this is the most important layer for all biological activity, since rainfall, snowfall, all the types of precipitation and these other weather phenomena are occurred in this layer, okay, and so this is the most important layer of all biological activity. And the zone separating the troposphere from the stratosphere is known as the Tropopause, as you may be seeing here, okay, here this is Tropopause. So here we have stratosphere and here we have troposphere, and this zone separating stratosphere and troposphere is known as Tropopause, and the temperature at the Tropopause is about minus 80 degrees Celsius over the equator and about minus 45 degrees Celsius over the poles. Temperature here at the Tropopause is nearly constant. See here, you may be seeing that here it is constant, okay. With increasing height, there is no change in temperature. You may be seeing in the another diagram also. See here in this case also. Here, okay, you may be seeing here that temperature remain constant with increasing height in the Tropopause. And you must know that Tropopause, okay, act as a lid of a container. Okay, Tropopause act as a lid of a container, And that is why, let us say, here we have tropopause, and since it acts as a lid of a container, say dust particles, then water vapor cannot pass through this layer, and that is why we find maximum concentration of this dust particle, water vapor, okay, in this layer. When there is volcanic eruption and other activities, only at the time it can pass through, okay. Otherwise these dust particles, water vapor cannot pass through this layer, and that is why it is said that tropopause act as a lid of a container. Any question, boys and girls?
No, sir.
Okay, then next we have the second layer, that is the stratosphere. So you have known that stratosphere is found above tropopause and extends up to the height of 50 kilometer. Okay, and I think you may be seeing here, it extends up to the height of, see here we have this stratosphere, and it extends up to 50 kilometer. Just see here, it extends up to the height of this 50 kilometer. And one important feature of stratosphere is that it contains ozone layer. And about the importance of ozone layer that you have learned earlier, this layer absorbs ultraviolet radiation, okay, and shields life on Earth from intense harmful form of energy. So this is the significance of ozone layer. And here in this diagram also, see here, we find maximum concentration of ozone in the stratosphere. Okay. See, we have just learned that this ozone layer, ionosphere, absorbs ultraviolet radiation. Actually it is mainly because of this formation, okay, of the ozones that ultraviolet rays are used. So I will show you, I will present you one diagram. Okay, see here, you must know that, okay, these ultraviolet rays okay, are filtered mainly by the creation of and the destruction of ozone. That means ultraviolet rays are used for the creation and for the destruction of ozones naturally, and by that process, okay, so this ionosphere this acts as a shield. That means absorbs. Now let us see the process. See, in this case, see, when ultraviolet rays having the wavelength of 100 to 240 nanometer, okay, strikes on the these oxygen molecules, okay, O2 here, then this oxygen will be split into two these atomic oxygen in this way. When UV ray having the wavelength of 100 to 240 nanometer, okay, on the these molecules, oxygen molecules, then it will be split into two atomic oxygen in this way. See, O2 will be split into two atomic oxygen in this way, and again another this molecular oxygen will combine with this one atomic oxygen, and because of that this ozone O3 is formed here. Just see here, okay, see here, this atomic oxygen is combined with one molecular oxygen, and ozone is formed. And likewise, see that another atomic oxygen is combined with, okay, one molecular oxygen, and this one ozone molecule is formed. Okay, then in the other case, when UV ray, okay, UV rays having the wavelength of 240 to 315 nanometer strike on this ozone O3. Then this O3 will be split into one atomic oxygen and one molecular oxygen this way. Okay, when UV ray strikes on it, then it is split into one atomic oxygen and one molecular oxygen, and this molecular oxygen, okay, this molecular oxygen, this atomic oxygen, okay, this atomic oxygen may combine with another atomic oxygen and form one molecular oxygen. See here, this atomic oxygen here is combined with another atomic oxygen and a new molecular oxygen is formed. So in this way, because of this influence of the UV rays, ozones are formed and destructed continuously. This is a natural process, and because of the formation and destruction of these ozones naturally, okay, under the influence of UV light, these UV rays are filtered, or in other words we can say UV rays are utilized, and in this way we are protected. Okay, remember, you must know that these ultraviolet rays, okay, are utilized for the creation and destruction of ozone in the ozone layer, and in that way this ozone layer is formed. Any question from your side? You may be wondering that this ozone layer absorbs ultraviolet radiation. Actually, because of this creation of the ozones, okay, creation and destruction of the ozones, that ultraviolet rays are utilized or absorbed. So because of this, since these ultraviolet rays are utilized or absorbed, okay, we are safe. Life on the earth are safe. And next we have another layer, that is Mesosphere. Mesosphere lies above the stratosphere, which extends up to a height of 80 kilometer. Okay, as you will be seeing here. Here we have this Mesosphere. And remember, you must know that in the stratosphere, temperature increases with increasing height. So this is due to the presence of these ozones. Okay, so high energy ultraviolet rays are utilized for the creation and destruction of the ozone, and that is why temperature increases. And just above the stratosphere we have the stratopause. Okay, so this is the transition zone between the stratosphere and the mesosphere. And in the mesosphere, you must know that temperature is again decreases with increasing altitude. Okay, as mentioned here, see, temperature once again start decreasing with increasing altitude, and recess up to minus 100 degrees Celsius at 80 kilometer. Okay, at 80 kilometer, see here, at 80 kilometer temperature recess minus 100. Okay, see, nearly 100. And see here in this layer, okay, the ionosphere, a layer containing ions, is located between 80 and 400 kilometers above the this mesopause, that is in the thermosphere. Okay, just see, let us see. Let's see, above the mesosphere we have this mesopause, and the next layer above the mesopause is known as thermosphere, and it starts from 85 kilometers above the ground. Okay, and this thermosphere contains electrically charged particles known as ions and as well as electrons. Okay, and see here in the thermosphere we have a very important layer known as ionosphere. Okay, so this ionosphere contains electrically charged particles known as ions. Just see here, known as ions, and hence this layer is known as ionosphere. And this layer is very important for the telecommunication. See, radio waves transmitted from the earth are reflected back to the earth by this layer, and hence it helps in the telecommunication. Just we have a very simple diagram here. See, here from the radio station, radio waves are transmitted, okay, towards the sky, and here we have this ionosphere, and this ionosphere reflects back the radio waves, okay, on the earth surface, and in this way we receive the signals here, and we can listen to the radio also. So this is the most important feature, okay, or the significance of this ionosphere. Remember, ionosphere contains electrically charged particles known as ions, and these ions reflect back radio waves to the earth surface, and thus it helps us in the telecommunication. And the temperature here in this layer is again increasing in the thermosphere. See here, increasing. It is increasing. This is mainly due to the presence of these ions as well as electrons. Just see here. Okay, see here, it increases, temperature increases. And the uppermost layer of the atmosphere above the thermosphere is known as the exosphere. Okay, this is the outermost layer of the atmosphere, and so this is the highest layer, but very little is known about it. And whatever contains there, maybe these gas molecules or other particles present there, are extremely rarefied in this layer. That means air is very thin. Okay, air is very thin in the exosphere, and this layer exosphere gradually merges with the outer space. So this is the last layer of the atmosphere. Okay, and see here about the pressure condition. Just see here. So this line shows the condition of pressure, okay, with increasing altitude, and here near the ground, just in the tropopause, just see here. Okay, here at the sea surface, at the sea level, this pressure is about 1000 millibars. The actual one is 1013, but here we are putting 1000 at the sea level. And you may find that temperature, okay, temperature decreases rapidly within the troposphere, and up to the height of these 30 kilometers from the ground, air pressure decreases rapidly. Okay, so at the height of 30 kilometers from the ground, so it is nearly these 50 or 60 millibars. Okay, and beyond this there is a constraint, okay, in the pressure condition. And so one more point you have to know about the this ozone layer. Okay, so we are learning about this ozone layer depletion and how ozone layer is depleted. Okay, will be discussed in the coming chapters, but that chapter may not be learning because it has been deleted by CBSE for this year. So let me introduce about the depletion of the ozone layer. Okay, so we know that see CFC, okay, chlorofluorocarbon. So it this CFC gas, okay, destructs the ozone layer. We have learned earlier about it. Okay, now let us see. So here ultraviolet rays, okay, see here different types of ultraviolet rays are here. Ultraviolet rays split a chlorine atom from the CFC molecule. So this is what? This is CFC molecule. Okay, CFC. Here this chlorine, okay, chlorine is here, chlorine, then fluorine and carbon. Okay, this is carbon, then chlorine, and this is fluorine, that is chlorofluorocarbon. Okay, this is CFC molecule. And when UV ray strikes on this CFC molecule, then one chlorine atom is separated. Okay, one chlorine atom is split, and this chlorine atom will again react with ozone. Okay, so this is the separated one, the separated this chlorine atom, and this chlorine atom will react with the this ozone. Okay, reacts with this ozone, O3. Okay, reacts with ozone, and the result is that it breaks. When chlorine atom reacts with the this ozone molecule, then it breaks off. One atomic oxygen is breaking off. Okay, and this atomic oxygen will, okay, bind with this chlorine atom and to form chlorine monoxide and leaves O2 behind. So in this way oxygen is again leaving behind. Okay, let me repeat. See here, when ultraviolet rays heat strike on the CFC molecule, one chlorine atom is separated, and this chlorine atom reacts with this ozone molecule, and because of that one atomic oxygen is breaking up, and this oxygen atom will combine will bind with the chlorine. Okay, with the chlorine, and to form chlorine monoxide, and because of that process, okay, one oxygen molecule is leaving behind. So in this way, because of the presence of CFC, okay, in the atmosphere, ozone layer is depleted nowadays. Any question from your side?
No, sir.
And see here, temperature, pressure, winds, humidity, clouds, and precipitation. So these are the important elements of weather and the climate. Okay, and this will be learning in the coming chapters. Okay, and that is why it is also mentioned here. See, these elements will be dealt in detail in the coming chapters 9, 10, 11. Okay, we are going to learn chapter 9, and okay, so in that we shall discuss about it in detail. So this is the end of this chapter 8, composition and the structure of the atmosphere. Okay, so if you don't have any other questions, so let us stop here for today. Thank you very much for joining my class.